Thanks for coming and really appreciate your time on Saturday, coming from various different locations to the center of the city. Really appreciate and thanks for being here. We're going to have two talks today. One is ClickHouse talk and other one is from our customer who's going to talk about the performance with ClickHouse in their organization. With that, I would like to introduce quickly our team. Cheryl, whom you are seeing, she has flown from Singapore to this meetup, and she's our head of marketing for APJ, right? And Meet, who leads our startup business for India, and Yadu, who is co-founder and CEO for Keyboard BI. So as I said, we just have two talks today. It will probably be an hour or somewhere around that time. So we'll try and cover ClickHouse, introduction to ClickHouse, plus a bit of observability as well. Since we talked about, we had a quick interaction with few of you guys. I'll try and keep the talk more specific to ClickHouse and then introduce a little bit on observability side as well. And then Yadu sir will give a quick demo plus presentation on Keyboard BI as well. All right. Let's start with ClickHouse. So how many of you have already used ClickHouse, whether it could be open source, cloud, any other flavors of commercial offering? Very few. Okay. That's good. And how many of you are from, let's say, developer background or DevOps? Okay, quite a bit. Anybody from students, from university? Okay, good. Nice. It's a good mix of people to learn about ClickHouse. We'll try and keep it, make sure to convey what ClickHouse and what are the deployment options we have. Where are we at ClickHouse Cloud? How could you leverage ClickHouse Cloud, right? So before we get into ClickHouse, a quick journey of how ClickHouse actually started, right? So ClickHouse is there from quite some time now. It's almost there from 2008-9. That's when the first prototype started. If you know Alexei Milivido, who is our co-founder, CEO, and creator of ClickHouse, who used to be at Yandex. It's kind of a Google in Russia. So he developed the prototype there back in the days when there was no system to handle a very large amount of data in a data warehouse. So that's where you see the terminology ClickHouse coming from clickstream data warehouse. So that was the use case which he tried to develop, having a massive amount of data, putting into a data warehouse. So the clickstream data warehouse becomes ClickHouse. And 2012, we went into production of open source and a lot of adoption in the community members. And 2016 is when we decided to release this in Apache 2.0 license, right? So 2016 becomes open source. 2021 is when the company has incorporated as ClickHouse Inc. That is where the journey of ClickHouse Cloud actually starts, right? Our CEO, Aaron, Yuri, and Alexei decided to start the company along with the open source development which we have. Starting from 2021 till 2025, we are at the end of 2025. First, it started with all about structured data, storing a large volume of data and a database / data warehouse. But in just 3 or 4 years, right? So we built an amazing product, which actually not just a database now, it has become a data platform because it has so many features and capabilities now which supports full text search, vector search, observability. We acquired recently a company called HyperDX, and Meet will also touch a little bit on ClickStack as well. So a lot of other features and functionalities like semi-structured JSON support, spatial support, board. So it becomes unified data platform, not just a single database now. So a lot of investment has also gone now for FY25 and 26 in terms of AI/ML as well. So there's a lot of work going on in terms of data lake as well. Now you can actually go and query easily from any data catalogs. It could be AWS Glue, it could be Unity, query your iceberg tables easily with ClickHouse. So basically you can use ClickHouse as just a query engine, or the main purpose could be used as a database itself, right? So we also have a massive amount of community support. Those who are using open source would probably already know that. So we have over 40,000 GitHub stars, which is slightly outdated, I think. So now we are over 41 probably. We are just close to where Spark is in terms of GitHub stars and the massive amount of community members out there. So what is ClickHouse? ClickHouse is a database. I can say it's kind of a relational data management system built to handle a different kind of workloads, right? So mainly specifically built to handle analytical workloads, which is typically the industry standard OLAP space. So not very great for OLTP. You have a lot of systems which can do great transactional system. That's because how we store the data, how we retrieve the data is very important. So each use case has its own pros and cons. So a lot of transactional system will not be able to handle analytics at scale, right? So if you have petabytes of data and running some complex aggregations of that, will not be able to solve with MySQL, Postgres, or Oracle, Mongo, etc. So you have to have a very good, solid analytical system where you get a millisecond to second kind of performance and the latency. That's where ClickHouse comes into picture. Blazing fast analytics, as I talked about, with massive volumes of data, which is a key feature. Right. Some of the other important aspects I would like to touch upon is it's SQL based, right? So if you know how to write a SQL query in MySQL, probably it's almost same. It works on ANSI SQL base. Almost 95% of all of your queries, which is similar to Postgres or Oracle, will work. So the learning curve with respect to language is not so much, easily adaptable, which is what I meant. Process the data very fast. That's very, very important, especially when you have terabytes to petabytes scale of worth of data. If you keep scanning a lot of data within the database, it will always be a latency issue. How efficiently you retrieve only a subset of the data is very important. That is where how you store the data and how you retrieve the data is very, very important from the architectural perspective. And ClickHouse excels that. And most of our customers, if you look at our blogs of our customers, they all talk about the great compression mechanism. We get almost 90% of compression, almost, which is 10x. Let's say if you have 1 terabyte worth of uncompressed data, probably you would end up storing just 100 GB of data in ClickHouse. That's a great compression mechanism. You get it. That's what I talked about, highly efficient storage and easily scalable to any size. So especially in ClickHouse Cloud, you get a very good auto-scaling feature where you really don't have to worry on how your workload gets spiked. It automatically scales up and scales down based on your workload, based on your query patterns, and how you initiate your read and write request to the system. Yeah, I talked about SQL there. So a lot of writes. Another important point, if you are looking for a very fast data ingestion, let's say millions of records of ingest per second into the system, then ClickHouse is really built for that. There are a lot of mechanisms how you can ingest that data, whether it could be from streaming platforms, whether it could be from object storage, whether it could be from your hotel collectors coming from various sensors of telemetry data. So Some of the examples, if I want to give, Tesla is streaming almost a few billions of records per second with ClickHouse. Netflix is storing few petabytes of data per day into ClickHouse. That's the volume of data which I'm talking about here. Distributed. Again, very important concept, especially when you're started using open source. It's highly distributed. You create multiple charts, multiple replicas. The queries gets distributed to each of the shards, and fetch the data parallelly to serve the request very easily. Highly efficient storage, I talked about the compression mechanism. There is a lot of different compression algorithms also which you could choose apart from the default ones, but it works pretty amazing. Like getting 90% compression for any kind of a data when you're storing in ClickHouse, and to operating on the encoded data is really impressive. Very fast queries because it scans and processes billions of records per second. We use vectorized query engine, and we use sparse primary index, which I can touch upon a little bit on that as well. How you can skip the parts and the granules. Parts and granules is nothing but the logical unit of the data. That's where the data gets stored, right? So parts you can think of it's kind of a folder where you have your ClickHouse data in a logical unit called granules. Joins and lookups, we have great optimizations done from a couple of years, especially from the joins. So now we are coming with the join reordering, lookups. There are a lot of various different table engines. You could, query the data from different databases altogether. We have multiple table engine, let's say MySQL table engine, Postgres table engine, S3 table function or table function, Kafka table engine. So you could bring all of these various data from different data sources easily and join them and do very fast analytical processing. Yeah, so use cases, very important. We categorize all of our use cases in these 4 buckets, right? So the main bread and butter of ClickHouse is that real-time analytics, and you could see some logos out there. If you want to make your applications really data intensive, when I mean data intensive, handling massive volumes of data at scale, right? So, and powering your applications to become very faster, or maybe powering your dashboards to become fast boards, I would say, right? So that's where the real-time analytics comes into picture. As soon as you stream the data from various different data sources, you should be able to immediately access that data, and that's where how effectively and how fast you ingest the data, and while the data has been ingested, how immediately you can query the data so that you can get the real-time insights is very important. Business intelligence, yeah. So again, this is one of again core use case for us. So we'll talk about Keyboard BI as well. So we have connectors with a lot of different various BI visualizations tools or ETL tools out there. Maybe Power BI, Tableau, you name any visualization tools out there in the market. We have native connectors with them, and you should be able to query the dynamic filters as well, which is kind of a really challenging, especially when you're dealing with small systems like maybe MySQL or Postgres. Machine learning and generative AI, again, this is one of our priority for financial year 26 as well. We have done a lot of investments there. Now recently we acquired a company called LibreChat, which is kind of a UI layer for your agentic analytics. If you have used something like Claude or maybe ChatGPT or any other UI tool, so it's kind of completely open source. Now it becomes an open source agentic stack where you could play and plug in your LLMs and use RAG methods or deploy a bot agent and ask any kind of insights of your data, which is pretty cool. And we also have Ask AI, which is in beta in ClickHouse Cloud. You could actually interact with the data which is already stored in ClickHouse and generate the reports and ask any insights if you want, right? So when you log into ClickHouse Cloud, you could also enroll for that, which is the beta feature, and try out how effective it is. Another important use case which we are dealing is logs, traces, and metrics, which is observability. As I said, we recently, a lot of companies back in the days were also, ingesting millions and millions of events or logs per second into ClickHouse. We have a lot of examples of storing petabytes of logs into the system, but we didn't really had a good visualization layer of observability layer on top of ClickHouse. So HyperDX actually completes that. So now we call this as ClickStack. So if you have the data stored in your ClickHouse, then you can easily use ClickStack to analyze your logs, identify where the errors are, what has happened, and takes the relevant actions against each of those error messages with the traces and metrics as well. Yeah. Important thing is we have multiple offerings of ClickHouse. Very important to know. We have great community of ClickHouse open source. That's one offering which ClickHouse has, which anybody can go download and use it, or use a Docker, or spin up a Kubernetes cluster and start deploying your own ClickHouse and start pushing the data into the system. With ClickHouse as a company, we offer a couple of other deployment options, which is ClickHouse Cloud. Most of our customers, probably more than 95% of our customers, use ClickHouse Cloud. I'll talk a little bit on the architecture side as well, which actually have a major difference of architectural comparisons there when compared with open source versus ClickHouse Cloud, which I'll talk about, right? And we also have launched now Bring Your Own Cloud, where you can actually, if you're using AWS, you can use your own VPC so that the data plane will be in your VPC. The data doesn't leave out of your environment, right? But ClickHouse Cloud comes with a completely managed offering. You might have seen the other managed SaaS or DPaaS offerings. It's very similar to that. That's one, and we are also coming up with ClickHouse Private for a very closed environment or air-gapped environment kind of scenarios. That's probably coming early next year as well into the system. So the main difference, if you look at from self-managed open source ClickHouse versus ClickHouse Cloud, there is a lot of architectural pattern differences here, right? So in open source, if you really want to effectively maintain and manage, you should have multiple shards there you're seeing, and for high availability, you should have multiple replicas to maintain and manage that. So actually, if you want to have two shards, then probably you might also have to have two replicas or one replicas, which actually is kind of an increase in the infrastructure. But the core engine remains the same, right? So a lot of community members have already contributed to various other features and functionalities. The main architectural pattern difference is that. So you really don't have to have now multiple shards and replicas with ClickHouse Cloud. It comes with single shard, unlimited database. All of your data is backed by object storage, right? So based on your query pattern, the data will be fetched from the object storage and kept in the second layer, which you are seeing there, which is called as compute nodes. That is where all of your query execution, the reads and writes basically happens via this second layer, which is compute nodes, where we have deployed in Kubernetes environment in the cloud provider which you choose. There are a lot of other aspects of it, some of the major feature comparison as well, which is like a cloud-only feature, for example, ClickPipes, where you can easily bring the data from different data sources, separation of compute and storage, compute separation, where a lot of other things, right? So the main difference here in terms of table engine is in ClickHouse Cloud, we now call it as shared merge tree, because the data is shared between your compute node and your object storage, right? So all of your replicas, we call replica is nothing but a compute node which handles the query execution. that will be now shared with the object storage. So it's pretty easy to work when you start using writing and reading the data. A lot of benefits and advantages. Doesn't have to maintain, manage, and comes with a whole lot of features and functionalities like monitoring, alerting, and all of those capabilities out of the box with the system. Yeah, some of the architectural patterns. So if you see, as I was talking about, there's two ways how you can define your data, right? So one, you could put your data in a row-oriented system like transactional system that becomes excessive discretes, but very great for fast, single lookup kind of an operation. If you have a lot of updates and delays, and maybe used for operational kind of a use cases, it's really great. But when you are looking for a column-based approach, then you need to have a very efficient storage pattern. The column pruning is very, very important. It only picks the number of columns which you need to query, not the entire data set. Whereas in the row system, it has to go to a particular row based on whatever the index that particular database is used. It could be B-tree index, it could be in-memory based skip list indexes, whatever it is, right? So here we use something called a sparse primary index, where you do a column pruning very efficiently. Thus, you avoid a lot of unnecessary columns while bringing that data into compute nodes, which you saw in the second layer in the last slide. Vectorized query execution. So we use vectorized query engine, which process a very large arrays, which could be the entire length of the column loaded into the memory. So that's very, very important, especially when you're executing a query in the system, right? So these are some of the basic differences of when to use the column-oriented system, when to use the row-based oriented system. Yeah, just a double click of how the data inside ClickHouse looks like, right? So how the data is actually stored here is, I don't know if you can see this really well. I talked about something called as parts. In the parts, there will be granules. Each granules is set of records. So it is almost 8192 records. Each granules contains 8192 records, and each granule will be mapped to its sparse primary index. So one entry per granule will be there in the primary index, and that will be stored in the memory. And now, if you really have a very efficient strategy of sorting column and the primary key column, you could actually go and fetch only the relevant granules, not scan the lot of other granules. That's where your query latency actually gets improved. So there's also skip indexes, which is kind of a secondary indexes where you can, very helpful if you have a lot of aggregations like min, max, average and all, you could put a skip list index on top of that and make it really fast. Yeah, so parts, as I was talking about, so this is the logical folder, how the data is stored. Let's say if you start inserting any data into ClickHouse, it creates something called as parts. Let's say insert into employee, etc. Insert into employee values, blah, blah, blah. It will create one part. So it's very important to actually design your system so that you don't end up creating a lot of parts. What eventually happens is all of these smaller parts gets merged into bigger parts, and then again the bigger parts gets merged into other bigger part, and finally flush down that to an object storage, right? So if you have a lot of parts, if you don't have effective batching processing when you're ingesting the data, then it could be a problem. Especially when you're streaming millions of records per second, you should be careful about designing the system. We also have something called async insert, which you can go and look at it, where engine takes care of batching the records internally as well. So if you don't want to really do it at the application layer, but very important, more number of parts is equal to more number of merges in the background. More number of merges is equal to more number of resource consumption. More number of resource consumption is directly proportional to your cost in the system. I this is how the traditional data warehouses currently in the enterprises looks like. They have multiple layers of the data system, data coming in from various data sources like servers, raw data sources, and then they introduce the streaming layer. They'll have to introduce the batching layer, then push it to the lake house, and the lake house could be multiple based on the different use cases, and then you do an ETL on top of that, and then you push it to the data warehouses, right? So it's really a bit complex. And then again, if you have OLTP systems to manage your transactional work, it has to talk to OLTP and the data warehouse. Again, the data movement, the silos will be longer, and data insights or time to insights will be very faster. But how we do at ClickHouse is all of your real-time data warehouse use cases, whether it could be observability, BI, real-time analytics, or machine learning and generative AI, all of these can be handled in one unified platform. We have direct integration, as I was talking about. ClickHouse now can act as a query engine as well, can directly talk to data lakes, right? So you really don't have to move the data between the data lakes to databases. If you have the data sitting in Iceberg, or Hoodie or Hadoop or HDFS system, so it's very easy to go and query the systems as well. And I'll talk about a great feature in the next slide. So we have the internal connector, which can actually bring the data in a real time, the CDC fashion from the databases like Mongo, MySQL, and Postgres as well. And then you have data warehouses, or you can connect to various visualization tools on top of ClickHouse to get your data and visualize that in the front end. Basically, in the last slide, it reduces the system bloat and increases your resource efficiency is what the takeaway of this slide. This is what I was talking about. ClickPipes, amazing feature. I think we launched this year and a half back. We do have a lot of open source connectors like Kafka Sync connector and various other things to bring the data, but this becomes completely managed offering within ClickHouse Cloud itself. Now, if you have all of these data, this is very limited data sources which I'm showing the slide, but now we have more than 20 plus data sources which you can integrate with ClickPipes and really bring the data into ClickHouse in a blazing fast manner. Yeah, you could always go and sign up for ClickHouse Cloud and maybe just use, if you have we also have some examples of having a really good amount of data in S3, and you can directly connect to S3 and start streaming into the system, right? So yeah, so have a various variety of sources like Kinesis, Postgres, S3, Google Storage, Azure Blob Storage, and a few others as well. This is the secret sauce of ClickHouse Cloud, which is not available in open source. We will not get this into open source because the architecture is different. As I was talking about, this is what the shared merge tree design of ClickHouse, where you do a separation of compute and storage. So you have your compute nodes, you have your object storage, and you have the keepers. There will be multiple keepers who manages the metadata of this information. It exactly knows which granules and which parts are present in this object storage, so that it can go and do a column pruning and not scan a lot of columns or data in the object storage, right? So what is the benefits of this? This is only one shard. There's no multi-shard concept at all. It's a single shard, unlimited database, virtually limitless database is what I would call this. Very high insert throughput, fast scale-up, scale-down operations comes with the separation of compute and the separation of compute storage, separation of compute and compute. Now we have a direct integration with the data lakes and the ClickPipes itself, and various other features and functionalities, right? And it really, not compromised with the TCO and the reliability guarantees, because all of your data storage is in object storage, and you have, for high availability, you have the multiple compute nodes. We usually recommend to have at least 3 nodes in the enterprise sector, at least, so that you have the data present in these, the faster access to the data present in these compute nodes, and even if one of the compute node goes down, you really don't have to worry about it. The read and request goes immediately, and there's no downtime. compute separation, what is this? It's mainly used as a workload isolation. Let's say if you have different kind of a workload, I have seen this, a lot of customers are actually using this. If you have a very heavy workload, a lot of write throughput, then what I could do is I can actually create one namespace, one service dedicatedly just for ingest, and the other services dedicatedly for maybe ad hoc querying, maybe for reporting, analytics, and things like that. So that these workload will not impact the other workloads, right? So you don't have a resource contention there, and the entire, all of these, you can have n number of services in the compute separation, but we will have a shared object storage, right? So even if you query from this service or this service, the object storage is same, so that the data is same between these services. But you will get the dedicated endpoints for these services, where you can go and connect to your application. Somebody from your dev team or a reporting team can use the other endpoint for analytics or ad hoc reporting, etc. Good. I think we let's talk a little bit on the observability. I'll let Meet talk about what is observability space, what did we do in recent few months, and where we are heading towards observability in terms of ClickStack, etc. And a lot of customers you can see, and Meet will also touch upon that, who already uses ClickHouse for observability with ClickStack, right? So then I'll after that we'll have a quick demo, just a short video of how the UI of HyperDX or ClickHouse ClickStack looks like. We'll show that, and then we can take any questions if you have. I can operate this. Yeah.
Hi everyone, I'm audible? Perfect. Right, so thanks Rakesh for giving us a quick overview on what ClickHouse really does. I'll focus on the observability use case. What you see on the screen are few of the customers, I'll say, who are using observability as of today, right? You see all the big names like Microsoft, OpenAI, eBay. The major use case I think that we are trying to focus here is how to build that one system that can handle all the logs, metrics, and traces inside a single platform, which probably is being utilized by other customers or other companies with 2 or 3 multiple platforms which are being managed as of today, right? Now, what we are trying to focus here is to create that single source of truth for them, where you host your data, you're pushing your data into ClickHouse. We just recently acquired a company called HyperDX, as Rakesh mentioned, which is again an open source observability platform. We are trying to integrate that with ClickHouse, which is known as the ClickStack, and then that's how you can bring in all these logs and metrics and traces and run your analytics over them, right? So that's what we are trying to focus on. Rakesh, if you can. Sorry. Now, getting into a brief history of observability, right? What you see here is the search and the metrics pattern over here, which were really different. Now, the search by the likes of Elasticsearch, which a lot of people would be using as of today, they are good at faster search, little faster aggregations, but it is very expensive, right? Because there's a lot of these reads which are coming in and out with the multiple queries which are being shot on a daily basis by most of the internal and the external users. On the bottom here, you see metrics. Prometheus is one of the most famous solution of the platform which is being used to run analytics on all the metrics. But again, right, with the increasing volume and the high cardinality of data, it becomes very difficult to manage these platforms. And in the end, it becomes really costly. If we get into the whole total cost of ownership kind of conversation, and you end up spending 30-40% more on a platform-to-platform basis. So what is the trade-off that I have seen, and probably Rakesh sees on a daily basis, is when you talk about search engines, they are cost efficient, they give you faster search to whatever data that you're looking at, but again there is the fast aggregation which is missing into these platforms, right? So whether you take Elasticsearch or any other platforms, that is what is missing as of today. And on the right is is the metric stores, where you have very limited search capabilities, but it is still, people still use it because it is not on the expensive side, and they give you very high or probably fast aggregations coming in. But what you see in the red is something that is missing in both the platforms, right? And can we avoid these trade-offs? Yes, it is possible. How do we do that? We do that using ClickHouse, the ClickStack that we just spoke about, right? So you get all three aspects into a single platform, as Rakesh also focused, right? We've got very high amount of data storage compression, right? So whatever your data is coming into ClickHouse has high compression ratio, so your cost against the storage part of it is automatically going down. Second is, ClickHouse again is built for faster, it's one of the fastest analytical platform, and that's how you get the fast searches, and you get high cardinality aggregations also, right? So all of these three aspects, which are the major aspects of observability, are covered under the ClickHouse ClickStack platform. Now, what we focus here is open formats. That's how you can integrate the platform with. You've got 10x to 100x compression ratio. I have seen customers who have close to around 50 TBs worth of data, bringing it down to around a TB, right? That's a massive compression ratio that we see, right? So that automatically saves a lot of dollar value in terms of how much data you're going to store, whether it is your external data coming in from multiple sources like Mongo, Postgres, MySQL, or any kind of logs or metrics or traces that we are looking at. Compute storage separation, compute separation. Data engineers, data science, or data analysts all have different workloads that they want to work on, right? But they are in the end going to query on the same amount of data that's being stored into your object storage or ClickHouse. With the help of compute separation, that becomes really easy. There is no resource contraction, and there are no latency issues that we face. And it is real-time fast. 500 GB worth of data, 100 GB worth of data, or probably I was talking to somebody here today who has close to around 1.5 petabytes worth of data. All of these use cases run really well inside the platform of ClickHouse. And this is the ClickStack, right? Right now we have, as I mentioned, HyperDX as the platform which is being used for running the observability use cases. But soon, probably in a month or two, we'll integrate that with our ClickHouse UI to run a ClickStack, where you bring in all your logs, metrics, and traces via OpenTel, which is one of the OpenTelemetry ETL tool to bring in all the data into ClickHouse. You store it in ClickHouse, and that's how you start analyzing all these logs and metrics inside a single platform, along with all your real-time analytics use case, all your data warehousing use case, and GenAI ML also. I'll probably let Rakesh run the demo.
Yeah, thanks, Meet. We have a recorded video just to show you how the glimpse of the ClickStack looks like. I just play this. You can see this is how the UI of the HyperDX or ClickStack looks like. There's a live log events coming into the picture, then you can see a lot of filtering options out there. You could identify the error patterns, and if you go to event patterns there, it actually aggregates the data and gets sorted and stored here. You get the event patterns, which is typically grouped by, and you can also look at what is happening if there is something wrong with the infrastructure, something is wrong with the traces, or explore the surrounding context as well. Not just the logs, it's a correlation between the logs and traces which you're seeing about. Starting from the front end, what's happening towards the back end is really easy for searching the traces and the logs and other, right? And you can see there's categories of logs and traces. Now you're seeing the traces now. If you look at all of the traces from the last one day, we know that the issue is something related to payment service, and then I dig more into details, and then you see the errors, and you look at the infrastructure for that particular trace and see what's happening inside the system, whether really it's a problem with credit card of the payment or the Visa cash systems and things like that. So ideally, you can boil down to each of the systems and see whether what is really happening in the systems. As I said, there was something related to the cache problem, which actually restarted a couple of pods in the system, right? So you can select some of the periods and just filter it for the event details and the slow events, and see which are the slow running events. Let's say the performance spikes are associated with this certain Visa transaction, etc. We also have Chart Explorer, which is kind of a dashboard, so you can build your own dashboard on top of the search. If you really want to look at, you can see some of the filter conditions there, and this chart shows the performance, how it is degraded from time to time, right? So you could see the difference of the performance degradation versus Visa card, or, with respect to Mastercard. So this demo is available public. I can share you the link where you can go, and actually this data is coming live. The payment data is coming live, and there's a detailed steps out there how you can go and search these logs, traces, and metrics, and how you can correlate between logs and traces and other things. Right. So just wanted to show you a glimpse of how ClickStack really looks like. One of our customer character.ai stores over 450 terabyte data every month, spending just 50% less than what they were spending in the other observability platform, which is really great. If you look at some of the data points here, it's almost 10x more data, 100x faster, 50% cost efficient for them, and it's public. You can go and read more detailed information about their system. I'll not spend much time here. There are a lot of enhancements going on, optimizations going on, new features being added into ClickStack and the observability platform. So JSON is coming very fast, which is almost 10x faster for the native JSON data type. Inverted index, which we already have in now private preview state, it will also come into ClickStack as well, making your the text search faster based on the inverted index. In-app optimizations, a lot of optimizations, especially time range searches, interest of the primary key, and reducing the scanning. All of the in-app optimizations and optimizations is going there. Lot more features are coming. As I said, import, export dashboards, spending fields, CSV exports. In inverted index now, it is actually in private reviews, not in experimental now, where you can actually go and subscribe for full text search and start using even with ClickStack as well. What's ahead with the platform of ClickStack? One of the most asked features, especially for the ClickStack, is GraphQL support, which is coming very soon, and ClickStack Cloud and some of the AI observability is also coming very soon as well. So you can actually do agentic AI kind of workloads attached to your log spaces and metrics, which is kind of really helps you dig down and identify what the underlying problem for, especially when you're looking at logs. For ClickHouse observability, you can just go to clickhouse.com/o11y and you get a lot of materials up there.